I welcome all of you that are interested in understanding this particular concept in maths. Let's look at the question. A geometric sequence is defined as negative 81, 27, negative 9. But before that, I want you to be aware that there are two types of sequence. There are two types. One is arithmetic sequence and the other one is geometric sequence. For arithmetic sequence, it has a common difference, and to calculate that, it is t2 minus t1. That's your second term minus your first term. So what does term mean? This is the meaning of term. Here negative 81 is the first term, so that will be t1. 27 is our second term, so that will be t2, t3. Then it goes like that. Okay. But for geometric sequence, it is a common ratio, not common difference, common ratio. So ratio means we have to divide. So t2 divided by t1. But for arithmetic sequence, it's common difference. So that means you have to subtract t2 minus t1. And for the nth term, what does nth term mean? Nth term means what term you are looking for. For example, here t1 is negative 81, t2 27, t3 negative 9. So if you want to find t4, that is your nth term here. So that 4 will go in place of n here, and in place of n here, then you will calculate its value. Also for geometric sequence, but you can clearly see that the formulas are different. Their formulas are different from each other. Okay, so this is the formula for nth term in arithmetic sequence. This is the formula for nth term in geometric sequence. This is the formula for the sum of the terms in arithmetic sequence. This is the formula for the sum of terms in geometric sequence. Okay, for example, if you want to calculate the first 10 terms, the sum of the first 10 terms, then it will be as 10. So in place of n in your formula, 10 will go there. Same here. Okay, but under geometric sequence, there is something that is called sum to infinity. Okay, and that is the sum of all the terms. That will be your sum to infinity, and that is the formula for sum to infinity, a divided by 1 minus r. But in order for you to use this formula, in order for you to calculate the sum to infinity, there are some conditions, and the conditions are your common ratio, which is your r, should not be equal to 0. Also, your r should not be greater than or equal to 1. And the last one, your r also should not be less than or equal to negative 1. I'll write not here, so that means it should not be less than or equal to negative 1. It should not be greater than or equal to 1, and it should not be equal to 0. If these conditions all holds, then you can use this formula to calculate the sum of all your terms or the sum to infinity. Okay, so we'll start answering the question now. First, we have to calculate r. So that means we have to calculate our common ratio, and for that the formula is there. This is under geometric sequence, so we'll be using the geometric sequence formulas. In order to calculate r, it says r equals t2 divided by t1. Okay, so if, to make things easy for you, you can label your terms t1, t2, t3. Okay, so you can clearly see there that your t2 is 27 and your t1 is negative 81. So you press that in your calculator. 27 divided by negative 81. There you can see it's in decimal. It's better you put it in fraction. It's negative 1/3. So it's negative 1/3. And that is our common ratio. Just if you want to check to prove that this geometric sequence is correct, you can use the other two consecutive numbers, and that is 27 and negative 9. You can divide negative 9 divided by positive 27. It should also give you this. So there you can see it also give you negative 1/3. So that means this question is valid. Okay, so we have already answered part A of the question. Calculate the common ratio, which is r. The answer is negative 1/3. For part B, we have to find the sixth term. So that means this question is asking about the nth term. So that means you will use the nth term formula, which is ar to the power n minus 1. So we will use that formula. Tn equals ar to the power n minus 1. Remember, this is geometric sequence. Don't confuse yourself with geometric sequence and arithmetic. Don't use the arithmetic sequence formula for geometric sequence question. That will be wrong. For geometric sequence question, just use the geometric sequence formulas. Okay. So what is A? A, that's your first term, or your T1, which is equal to negative 81. R you have already calculated from part A, which is negative 1/3. Okay, and here the n, since we are calculating the sixth term, so the n will be 6. Okay, so now we just have to put in the values and calculate. So our n is 6. We are looking for the sixth term. T6 is equal to, our first term is negative 81 multiplied by our common ratio, which is negative 1/3 raised to the power of n minus 1. Our n is 6, so 6 minus 1. Okay, so when we will further solve that, T6 equals negative 81 negative 1/3 raised to the power of 5, because 6 minus 1 is 5. And then you just have to press in the calculator. Remember the Bedmos rule says bracket first, after that the exponent or the power. So bracket and power is there, you have to solve that first, then we multiply to negative 81. This is very important, because if you do the other way around, then the answer will be something else. I'll solve it now. So it's negative 1/3 raised to the power of 5. So there the answer is negative 1/2 for the re, then multiply by negative 81. Okay, so that means the sixth term is 1/3. Okay, so that is our sixth term. T6 is 1/3. Okay, now we'll go to part C. Find the sum of all the terms. The sum of all the terms. So a number is not given. For example, it doesn't say find the sum of the first 10 terms. Okay, for that you will use this formula, but for this one it says all the terms, so that means to infinity. All the terms to infinity, so that means you will use the sum to infinity formula, but we will have to examine our common ratio. If it satisfies this condition, then we will be able to use the sum to infinity formula. So our condition says our common ratio, that is R, should not be equal to 0. So let's check that. What is our R? Our R is negative 1/3. Yes, it is not equal to 0. That's okay. Our R should be greater than, should not be greater than or equal to 1. So yes, it is not greater than or equal to 1. And the last condition, it should not be less than or equal to negative 1. Yes, it is not less than or equal to negative 1. Okay, so that means we can use this formula. So the formula says sum to infinity is equal to A over 1 minus R. Okay, what is A? The first term, which is negative 81. What is our R? We have already calculated from part A, which is negative 1/3. Then we just have to substitute these values in place of the formula. So A is negative 81 divided by 1 minus, remember this minus is from the formula, and our R is negative 1/3. So there should be 2 minus sign there. The 1 minus is from the formula, and the other one is from negative 1/3. Okay, then you have to calculate that. And remember, minus, that means plus. Okay, so that means it is negative 81 divided by 1 plus 1/3. I'll transfer this here. So it's negative 81 plus, divide by 1 plus 1/3. So what is 1 plus 1/3? Let's go step by step. It's 4/3. So that means negative 81 divided by 4/3. You can press this in the calculator, or there's a rule: when we divide by a fraction, we multiply by its reciprocal. Okay, but let us solve the one using the calculator first. So it is 4/3, then negative 81 divided by answer, because negative 81 divided by 4/3 is already there, divided by answer. Yeah, it is negative 243 over 4, or negative 60 point equal to negative 60.75. Or you can write its fraction form, the improper fraction form. It's negative 243 divided by 4. Okay, so both answers will be correct. Okay, but the normal procedure from here, it's negative 81 multiplied by the reciprocal of the fraction, so multiply by 3 over 4. Okay, so let us try that. It should give us the same answer. Negative 81 multiplied by 3 over 4. Does it give us the same answer? Yes, it gives us the same answer, which is negative 243 divided by 4, or negative 60.75. So that is your answer for part C, and that is the sum of all the terms, or in other words, your sum to infinity.